So fusion is the splitting of a heavy nucleus to form two or more lighter ones. Fusion is the combination of two light nuclei to form a heavier one. So fusion is fusing together, right? Fission is the other one, splitting apart. Both of these processes are highly exothermic. They form daughter nuclides with greater binding energy per nucleon. That's the scientific explanation for the exothermic nature of them. Fusion is the energy source of the stars, and it's also the basis of the hydrogen bomb. So nuclear fission was the atomic bomb. That was the bomb used on Japan in World War II. The hydrogen bomb is 1,000 times more powerful than an atomic bomb. 1,000 times. I mean, we've seen pictures and probably documentaries and things of the damage that those atomic bombs did in Japan. This is 1,000 times more force. So we've got this reaction occurring. Two different isotopes of hydrogen combine to form a helium nucleus and a neutron. So these are two different isotopes. The common isotope of hydrogen has just one proton and an electron, right? This one has a proton and a neutron, and so its mass number is 2. This one has a mass number of 3 because it's got 2 neutrons. So this one's called deuterium, and this is called tritium, prefix 2 and 3. The regular one is called protium. A small fission bomb is detonated to give the very, very high temperatures needed to start the fusion process. So in order to start the hydrogen bomb, you have to detonate a small atomic bomb. And then you get this reaction. Nuclear fusion would be really, really awesome as a fuel source, because you take some hydrogen, you smash it together, you get helium. Unlike fission, you're not getting radioactive daughter nuclides being formed. As a power source, this is a 10 times higher energy density. The products have very little problems. The big issue, though, is the temperature needed to sustain this reaction is so high that we don't know of any material that can contain it, right? So how do you contain something that's going at such a high temperature? So people are working on this. The tokamak fusion reactor uses magnetic fields to contain the fusing nuclei. It's just not at a point where it's economically feasible.